Okay, now it's time to discuss an example on simple harmonic motion. And what we have here is a simple pendulum. uh, and this simple pendulum has a mass m and a length L. So a simple pendulum consists of a mass which is tied to a string, and this mass can oscillate in an angular way, which means it's the angle which is changing with time. And similar to last example, what we are trying to achieve is a equation similar looking to is an equation similar to this equation. In the last example, x was the displacement from the mean central point. Uh, so x was the distance from the central point of the mass. In this case, is the angle which is some angle. So mass is some angle away from the central point. So the variable here is not distance, but the angle which is changing with time. So similar to last example, we begin by making free body diagram to achieve this equation for this new system. So we have our mass which is being acted by a force of gravity mg. Also there's a tension acting, and the block or the mass is actually moving like this. Okay, and now we have to start by writing the Newton's equation for this, and for that we have to describe our x-axis. So let's say this is the x-axis and this is the y-axis. Now we know the sum of forces in the y direction is going to be 0 because the object is not really moving in the y direction, but sum of forces in the x direction will be m times a, where a is the acceleration of this object for some angle theta. So this object is somewhere in between. Okay, which means what is fx? The only force that is contributing in the x direction is mg, because mg is neither in the x direction nor in the y direction. So you have to break it up, and for that you need to find this angle here. So what we can do is draw this line, and we know this angle is going to be 90 minus theta, and because this is perpendicular, this is going to be theta, and this angle is again going to be 90 minus theta. So simple using laws of breaking vectors or ideas of breaking vectors, all we have to do is write mg cos of 90 minus theta in the x direction, and cos mg sine of 90 minus theta in the y direction, but we are not really interested in the y direction. So it's this force that is acting in the x direction, which is a component of mg, and this is nothing but mg sine theta. Okay, so what is fx? Fx is minus mg sine theta. Why minus? Because it's in the negative direction. X is plus and this is the negative direction, equals m minus a, because a is also pointing in the negative direction, and that gives us g sine theta, uh, g sine theta. Am I making a mistake here? No, g sine theta minus ma equals 0. Well, sorry, you can write as ma minus g sine, I am sorry, a minus g sine theta equals 0. Well, it was not really required, but anyway, let's write it like that. Okay, what is a, by the way? Now a is going this side. A is the acceleration. So if a is the acceleration, then we know a is connected with angular acceleration as alpha times L, where alpha is the angular acceleration, because that is how the linear and the angular acceleration are connected. Also we know that alpha is d omega over dt, and omega is d theta over dt. So here uh, you can write alpha as d squared theta over dt square. Well, by x double dot we meant d square x over dt square. Okay, so that is a that is alpha. So what should I write? We should write alpha L times d squared theta over dt square minus g sine theta equals 0. Okay, now we have said earlier that all these are vectors. All these are vectors. So what is the direction of alpha? Well, this is just the magnitude, whether it's in the plus z direction or is in the minus z direction. We have defined our x-axis, y-axis. Z will be coming out of the plane. So if z is coming out of the plane, alpha is actually pointing in. So if alpha is pointing in, because you curl your fingers in the direction of alpha, as you curl your fingers in the direction of alpha, then um, your thumb should actually be pointing inside the screen. That means you should put a negative sign to make sure you put you choose the right direction. Okay, and that gives us d square theta over dt square plus g over L sine theta equals 0, and that gives us omega equals square root of g over L. And similarly we get t equals, this is the time period, L over g. So this is the time period of a simple pendulum, and this is the angular frequency. As you can clearly see, if we increase L, the time the pendulum takes will go up, and if we increase g, which means the gravity, then time taken by the pendulum will go down. As a matter of fact, if we go to moon, the same pendulum will take longer to complete one cycle. Okay, so this was an important point, choosing the right sign here. Always, we always have to be consistent with the direction of with the sign of the vector, because sign of the vector tells whether it's in the plus direction or is in the negative direction, or is it along the x direction or is it along the minus x direction or any other axis. Well, so the equation we have actually theta double dot plus g over L sine theta equals 0. Now you see this is not same as the equation x equals 0, because instead of theta we have a sine theta here. But the sine theta can be written as theta, or is almost close to theta, if theta is very small, and theta is being measured in radians. So this is an important point. So this equation becomes this one with small theta, and this equation starts resembling with this one. So this is an important point here, that a simple pendulum is a simple harmonic motion only for a smaller values of theta, and make sure that here theta is measured in radians.